Hey everyone, in this video I'm going to go over the review sheet for your test number 4. So the first question says state where the function is undefined. So undefined states that it would make a fraction undefined when the denominator becomes the value of 0. So all I really care about for this particular problem is the denominator. So what I'm going to do is I'm going to see, well, what value would make the denominator become 0. So I'm going to do that by setting this equal to 0 and factoring. So in this case, I can use the AM method because it's a trinomial. So I'm going to do AM, and I will get x plus and x minus, and the factors of 5 that add to 4 would be a -5 and a +1. Next, I would split this down the middle, and I would get, for this side, x equals 5, and then I would set this side equal to 0, and I'd find out that x would equal -1. Oops, that was silly. I don't know why I wrote it that way. -1. Okay, so this means that the values that make this function undefined are -1 and 5. In the calculator, what you can do is you can type this whole thing, the whole entire thing, into y equals, and you can look at the table and see where you see errors, but that's how you do it algebraically. This question asks you to factor. Because it has cubics and 2 pieces, it's usually factoring perfect cubes. We use the method SOAP with this one. So what I'm going to do is make a parenthesis here and then a bigger parenthesis here. And I'm going to spell the word SOAP out. The first thing I'm going to do is I'm going to take the cube root of the whole thing. So the cube root of this term, the cube root of this term. That'll help me get the first 2 terms. So I'm going to go to my calculator. I'm going to press math to find my cube root. And type in 216. And I get 6. So the cube root of that is 6. The cube root of j cubed is j. And the cube root of a cubed is a. Now, SOAP helps me with the signs. So same as what I started with. So plus, because this is plus, opposite now, which is minus, and always positive here. Now to get these terms, I use the phrase S, which means square multiply square. I'm going to square this whole entire thing to get this, which will get me 36j squared. And I'm going to square this and the last entire thing to get this. And that gets me a squared. And then the middle term I'm going to multiply. So to get the middle term, I'm going to do 6j times a. And that's just 6j a, which I should do in blue because everything's been in blue, but that's okay. So this is my answer right here. Okay. Next question is asked you to solve for x. X is in an exponent, so the thing you're going to have to use here is most likely logs, but the first thing you want to do before you put a log in or an ln is divide by 4, and I get 2x minus 2, and I'll see if 54 divides by 4, and it should. I think it's, oh, nope, I don't know my times tables. It's 13.5. And now what we're going to do is we're going to put a log or an ln in. I prefer ln, so I'm going to put an ln here and an ln here. This will come down as one whole piece. So it'll be x minus 2 ln of 2 equals ln of 13.5. Next what I'm going to do is going to start to solve for x. I need to divide by the ln of 2 first to make that happen. I'll get x minus 2 equals that. I'm not going to type that in. You can if you'd like, but to keep it completely accurate, I would want to keep the ln's in here. Next and lastly, to get the x alone, I'm going to add 2. Now, technically, this is an acceptable answer, but if they round, I think this one's a multiple choice question, or if they ask you to round if it's part 2, which I probably will. If I'd made it a part 2, I don't remember. You'd have to type this in. I use alpha y equals for this. Sorry, I don't have my calculator app on this device. and this would come out to about 5.755 if you do thousands. Yes, okay. So both are acceptable. This is, the one with the LNs is actually the more accurate one because it's completely a whole piece. Now, if you're going to want to check your answer, what you could do is go to y equals, and you could type in this side into y1 and that into y2, which would be a great calculator trick if you wanted to do it. So 2, I'm going to do it just so I make sure that I did this correctly, and then 54, and then I'm going to graph it, and then I'm going to hopefully see where they intersect. Now, you might not see where they intersect because it's all the way up 54, so I'm going to change my y max in my window to 60, and now I can see the intersection. So I'll draw you a little picture here. So on my graph, I see this guy here and this guy here intersecting. And when you do second calc intersect, and you drag that blinky dot all the way over, you press enter 3 times, you'll get the 5.755. So we know that that's good. Okay. This one asks you to write a recursive formula for this sequence. So remember, recursive, you need to write your let statement, which we just state a1 equals 4. So first do that. And then an equals something with an minus 1. We're not sure. We need to figure out if it's multiplying or adding. Now, adding wise, it would be plus 4 if we were doing this. But 8 plus 4 is not 16. 8 plus 4 we know is 12. So it's not adding. So let's see about multiplying. If I do 8 divided by 4, I get 2. And if I do 16 divided by 8, I get 2. And if I do 32 divided by 16, I also get 2. So this is a times 2 deal. So it would be 2 times this, and that should be your answer. Oh, and they want you to also find the next term. Okay, let's read the whole problem. So we wrote the recursive formula and then find the next term. All I do is times this by 2, and I get 64. So there you go. What would that be? 1, 2, 3, 4. So A5 equals 64 because it's the 5th term. That's pretty bad. Let's write a better A5. Good. Next question says find the directrix. What is the directrix of the given parabola? So let's see. The vertex of this is 1, 2 because it's the negative positive deal. And the a value is in here. This is the 4a part of the formula. So 4a equals 8. I'll give you the formula on the board or on the test. A equals 2. So a equals 2. This means that that distance is 2. And this one opens up because it's x squared and there is no negative sign in front of the 8. So what I'm going to do is I'm going to plot 1, 2. So x is 1, y is 2. This is my vertex. We know it opens up. And then I'm going to count 2 up. 1, 2 for my focus. And 2 below. 1, 2 for my directrix. So this should actually be my directrix down here. 1, 2. Yep, so my directrix is what they want. They want the equation. My directrix is the x-axis, but as an equation, the directrix would be, you're going through the y-axis, so y equals 0. Okay, this one says, suppose you deposit 2 cents into your piggy bank on the first day of January, and each day of January after that you deposit twice as much. So we do 2 cents to start, so that's 0.02. On day 1, that's probably A1 in a sequence. And then we do twice as much the previous day. They want you to use the geometric series formula. They're actually telling you this to find how much you'll have in the bank after the last deposit. We're doing it in the month of January. There are 31 days. So this geometric series formula is on your reference sheet. Sn equals A1 minus A1 r to the n all over 1 minus r. Okay, and then I'm going to plug in. So I want the sum of 31 days, so that's your n. A1 is 2 cents. We're doing twice as much on the previous day, so that means r is 2 to the n. So, of course, that looks sloppy, so let's make it better. And then 31 days all over 1 minus 2. And let's see if this gives us a nice number. So I'm going to type this literally in the calculator the way I see it. Alpha y equals, so you got the fraction, 0.02, because it's cents, 2 to the 31 over 1 minus 2. And I get, in my calculator, 42949,672 and 94 cents. So 1, 2, 3, 1, 2, 3. So $42,949,672.94. Okay, next question asks you to graph this logarithm. So all I have to do is go to y equals and plot this in. So to get the log, I think it's alpha window. Yep, if you press alpha window, you'll see log base, and you're going to do 3, and then x plus 2, and then minus 4. And I'll press graph. Make sure I press zoom 6 so I reset my window because we've been doing a lot of trig graphs, so you want to make sure you see it. Okay, so I see a graph here, and I'm going to go to my table to get points. Now you want to look for the first error, because remember with log graphs there is an error. If your scaling is wrong, remember to reset your table set, because I know we've been doing trig, to reset the table set to start at, I guess, 0 and change by 1. But -2 is really important because that's where the asymptote is. So I'm going to plot the asymptote with a dotted line. And you can see that the asymptote exists because this is positive 2. And if you can't have a 0 inside of a log, it's not allowed, it's undefined in that way. So you would have to know that -2 would make that 0. So now looking at this, I'm going to plot some points. So my first point on my table that I see I can plot is -1, -4. 1, 2, 3, 4. Okay, and then 0 is at like -3 and change. And then 2 is at 2 and a little bit more. 3. Oh, I made a little mistake here. I skipped a point. Hold on. So 0 is at -3.3. 1 is at -3. So that's why it was looking a little weird to me. Okay, 1 is at -3. And then 2 is at -2 and change. That makes more sense now. And then 3 is, again, like -2.5. 4 is another -2 and a little bit more. This is very close to, it's going to keep on getting closer and closer to 2, basically, it looks like. Until at 6, 1, 2, 3, 4, 5, 6 is exactly at, oh no, 7, it's exactly at -2. And then 8 is at a little bit above that. I mean, this is estimated. You don't have to do these many points at all. I'm just putting as many as I can to make it look accurate. And then 9 is here about, and then here about, whatever. So we connect our points here best as we can. That looks pretty good. And then I want to make sure I see that it skims along that x-axis, okay? No, not the x-axis, the asymptote. X equals -2. This is the asymptote, x equals -2. That's the asymptote. And then this is our equation. The second part of it asks you to state the end behavior. So there are two ends. On this end, I go to infinity and infinity. That's my end behavior there. And on this end, I'm going to technically -2 and negative infinity. If you think of it as a point, if you think of the end as a point, it kind of makes sense. So my end behavior would be as x goes to the right, y goes up, and as x goes to the left, it can't go all the way to negative infinity, it can only go to -2, y goes down. Boom. There's my infinity signs, they look terrible. That's fine. Okay, so solving for x here. Oh, what did I just do? Okay, subtract 2. Of course, you guys can go to your calculator and put y1, y2, which is the check actually if you want to start off with that. This would cancel, you get x plus 4. But this you have to do out because it's a binomial. squared, so you're going to have to do some box method here if you do that. Otherwise, you can do FOIL. Okay. And then this. I combine some like terms there. I'll subtract x and I'll subtract 4 to get this to 0 so I could factor. This gets you minus 5x, and these cancel, which is kind of nice. You have to use GCF here. There's no other type of factoring I can think of. There's an x that's common, and you take that out. Again, you set this equal to 0, so x equals 0 is one of the answers, and then setting that equal to 0, x equals 5 is the other one. Now you have to check. You must check. You need to make sure you don't have any extraneous solutions. So I'm going to go to y equals. This is my check trick. I'm going to put this into y1, this whole left side, and y2 will be just the x. So in y1, again, I don't have my calculator on the screen, but I'm in y1 right now. I'm putting in x plus 4 plus 2, and then I'm putting x into y2. I look at my table and I look at 0. Now 0 is not happy right now because when I look at my table, 4 and 0 don't match. But when I look at 5, I see 5 and 5. So I'm going to have to reject this guy, and I'm just left with the answer of 5. This one's extraneous, the 0. Okay, this guy here, find the inverse. Now, if this is multiple choice, what you could do is find a point, look at all the choices, and then find the point that is reversed, because the inverse's definition is when you switch x and y. I just wanted to make sure there was no choices here for me to pick from. So what I'm going to do is do this algebraically. So I'm going to make this y equals, and I'll do 20 x, well, you know what? We need to switch the x and y because that's what an inverse is. So let me just do that now. We all know that f of x means y, hopefully, at this point. So we'll make this x and make this y, and then this 5 minus y. Okay, so the first thing you're going to do is cross multiply. So you get 20y equals x times 5 minus y. Distribute this in. You get 5x minus xy equals 20y. Now, the goal here is to solve for a new y, but there's more than one y, so you're going to have to bring it on over with the other y. And this is where people get stumped. You have to use GCF here with the y's to make sure that you can factor. So the y comes out and you get 20 plus x. And now what you can do is divide by 20 plus x and get the y alone. And you have your inverse. That's it. Now to check your answer, what you can do is plug in a number. So let's plug in 0 for x. If I plug in 0 for x, let's see what I got. I probably will get 0. So if I plug in, oh, that's probably not a good example. Yeah, don't do 0. And I should have told you that. I usually don't use 0 to plug in. Maybe we'll try 1. Let's see what we get with 1. So if I plug in 1 for x, you can do this in your calculator too, but I'm just trying to show you what I get for y. Alpha y equals, that'd be 20 over 5 minus 1, which would get you 5, which worked out really nicely. So is this working? Oh, I hope so. Yeah, okay. Should be 5, 1. So let's see if I plug in 5, do I get 1? So if I put 5 times 1 over 20 plus 5, that doesn't work. Because it's divided by 25, that's 0.2. So what did I do wrong here? Do anything wrong? Well, I did something wrong. It just was very silly. This should be a 5 here because I'm plugging in 5 for x. That was so silly. And when I do 5 times 5, it's 25 over 25, which is 1. So this works out. Here's your inverse. That's the multiple choice trick, is to plug in a number get that number out, plug that number that you got out to the choices, and you should get the number that you originally plugged in. Inverse relationship. Okay. Second to last page. Let's do it. Oh. This is really nice. This is not what we want. These are all exponents. So hopefully I remember to fix that. They're all exponents. That's fine. They want you to justify why p plus 5 is or is not a factor. Now, the easiest way to do this is to plug in p equals negative 5 into all the choices. You could also use synthetic division and do it that way and see if you get a remainder of 0. But what I'm going to do is I'm going to plug in p as negative 5. And all of those little things I just drew are exponents. That was terrible that happened, but hopefully it's not like that on, I'll make sure it doesn't have that like that on the copies for you guys. This is the easy way to do it. It's the remainder theorem. You can basically plug in the factor when you set it equal to 0. In this case, you get negative 5 into all the choices, and you see if you get 0. So let me just see. So this was p, so negative 5 to the 4th, plus 6, negative 5 to the 3rd, plus 11, negative 5 to the 2nd, and plus 29 times negative 5. If you're doing in this method, make sure you use parentheses, just like I did on the paper in your calculator. So I'm just plugging it in. You need the parentheses because we're dealing with negatives. So I get negative 8. Hopefully I plugged that in right. Negative 5 to the 4th, 6 times negative 5 to the 3rd, plus 11 times negative 5 squared, plus 29 times negative 5, and then minus 13th. And yeah, I got negative 8. So because I got negative 8, it's not a factor. This looks really sloppy, so we're going to fix it because this is also my key that I want to post for you guys. Okay, so you're going to say p plus 5 is not a factor because when p equals negative 5, the output is negative 8, not 0. If it was 0, it would be a factor. Okay. Given the graph is the function even, odd, or neither, so this is a even, odd, or neither graphic question, which means that you have to look for symmetry. Remember, there are two types of symmetry, over the y-axis and the origin. In this case, this one has symmetry over the origin. So because this has symmetry over the origin, this is an odd graph, and you're going to say because symmetry over the origin. Even has symmetry over the y-axis, like they fold it over like the y-axis like a butterfly, and odd has it over the origin, and neither is neither. Use the property of exponents to determine a. So what you're going to do here is you're going to multiply these guys, so this is over 1, so this is really 2 to the 5th. This is power over root, so 1 over 5, so x to the 1 over 5. And then we want to make it just x to the a to find a. So remember, you add these together. So 2/5 plus 1/5 should be 3/5, but I will check that. 2/5 plus 1/5, and math fraction is 3/5. So it's 3/5 because they just want the exponent. Because technically it's x, and then these cancel out, so you get this. All right. I think that's it on this page, hopefully. Yep. Last page, people. Okay, nice. All right. So this one here says there's 1,000 coins shaken, the coins are emptied on the table, only the coins that land on heads up or return the box, blah, blah, blah. They tell you that they want you to write an exponential regression equation for this, rounding the values to the nearest 10,000s, which is 4 places, because 10,000 has 1, 2, 3, 4 zeros. That's how I think of it. And I am going to do this. This is all a calculator one. It's actually a nice, easy question to get correct. They want an equation, though, so make sure you have y equals. They want exponential, so they're looking for ab to the x. And we're going to do this by doing list 1 and list 2 in your calculator. This is L1, this is L2. So I'm going to go to stat edit in my calculator. I'm going to enter in the data. So I'm going to clear out what I have in here by pressing clear and pressing down. So I'll do 0, 1, 3, 4, and 6 for my first one. And then I'll do clear and down for L2, and I'll do 1,000, 610, 220, 132, and 45. And I'm going to hopefully, I'm going to check this is right first. 0, 1,000, 1, 610, 3, 220, 4, 132, and 645. Great. And then I'm going to do stat, calc, and I'll look for exponential regression, which is choice 0. And I'll press calculate on my calculator, and I'll get this lovely answer. So we're going to make sure we round to the nearest 10,000ths. So I get 1018.2839, 1, 2, 3, 4, and then 0.5969 to the x. That should be right. I think that's right. Let me just make this x look better. It's a little sloppy. 0.5969. Yep, that's 4 places. Okay, next one. Next one is getting the bottoms the same and crossing them off. So first off, factor the bottoms you can. I can factor this one with AM. Factors of -3 that add to -2 are -3 and +1. Oh my god, that's amazing because these guys have that. So all you have to do is give everyone what they don't have because they're jealous and they want the other piece. So this one wants the x plus 1 piece. Whatever you do to the bottom, you do the top. This one wants the x minus 3 piece. Whatever you do to the bottom, you do the top. Now that everyone has the same pieces, bye-bye. So I'll do 5 times x minus 3 equals 6 plus 1, x plus 1. Make sure you have the right sign that's here. Sometimes they put a minus sign and it throws you off. Distribute, so 5x minus 15 equals distribute. Don't get tricked with 6 plus 1, that's not 7 yet, plus x plus 1. Now I can add my like terms. That gets you 7. And combine like terms. So I'll add this guy over here. And I'll subtract the x over here. So that gets me 4x, and then 7 plus 15 is 22. And then we get divide by 4. This is not a nice answer. We got 5.5, but that's fine. At least we don't have to reject it. Remember, you want to look for values that would make the bottoms become 0. It can't be -1 and it can't be 3 for this question because this would make it undefined for that fraction. Hold on. This would make this fraction undefined, and this would make this fraction undefined. So that can't happen. But it's not one of those answers, so this should be acceptable, but we always want to check our answers. So I'm going to go to my regular window, and I'm going to do alpha y equals, and I'll do 5 over 5.5 plus 1. Get an answer. It's some weird decimal, that's fine. As long as it matches, we're happy. So 6 over 5.5 squared minus 2 times 5.5 minus 3 plus alpha y equals 1 over 5.5 minus 3. And they match, so this works. Make sure you check it. So I'll write check, because hopefully you guys remember to check. Okay, so, oh my god, last question. This is amazing. So, this is fun. We're going to box method this guy and that guy, and then bring them together. We're box methoding because they're squared. I know you're so excited. And then eventually we have to minus this and distribute. Okay, so 2x minus 3i. That doesn't look like an I. Okay. X squared, 3xi, 3xi, 3i squared. So that gets me x squared plus 6xy, oh, 6xi, I'm sorry. And then plus, that was dumb. I forgot to do 3 times 3, which is 9. I knew I'd missed something there. Okay, so 9i squared. Great. Okay, ignore the minus sign here because I'm going to do it here. So this is just 4x squared, and then 3 and 2 make negative 6xi. And then 3 and 2 make, this should also be a minus sign, negative 6xi. And then 9i squared, because negative negative make it positive. Okay, so I get 4x squared. Highlight this in red so I don't confuse you people on the key. All right, so 4x squared minus 12xi plus 9i squared. Now before I even deal with the I squareds, I want to distribute this in. So minus 4x squared plus 12xi minus 9i squared. Because actually what happens here is the I squareds cancel out. You don't even have to worry about them. If they don't cancel out, remember they reduce to negative 1. But what's nice here is these all cancel. And I do x squared minus 4x squared, which is negative 3x squared. And then 6 and 12 make 18xi. And that should be it. Now what's nice is you could actually type this into your calculator with the x and type this in, and you might get the same answer. You should get the same answer. This is a good check. I think it works if I'm correct. If it doesn't work, I'm going to find out right now because I'm doing it. And hopefully I did it correctly. So I enter that, get some weird number. And I think this works. So if I do 3x squared plus 18xi, I get the same thing. Boom. Okay, your review sheet is done. Good luck, study. I'll see you guys soon.